Welcome everybody to this week's Azure and AI Show. Um, I'm Frank Falvey from Cork in Ireland, and we have two new speakers with us this week. So we have Monica. Monica's going to do talk for us, and we have Raj there. He's going to go first with his one, and we want to say happy birthday to Hal
Happy
Holster.
birthday.
Happy birthday, Hal.
Thank you.
Hal, Hal is our MVP, and he's 31 years now in MVP. So thanks, Al, for joining us again. And I think Dan Ray will be popping in here again. So do you want to share your screen there? So that's right.
Okay. Yeah. Let me share my screen.
Yeah. So when you click on share your screen, then up on the top right hand corner, yeah, we got it there
You
now.
are able to see my screen.
Yeah, I can see it there now. Yeah. Interesting title.
Okay. Shall we start?
Yeah.
Okay. Um, Good evening, everybody. This is Rajneesh Kaushik. I'm very excited to present his first session um, in this webcast. The session is I gave an AI a job title, a badge, and a to-do list, and then see what happens. Everyone talking about AI agents. Very few people have built one that actually works in the real enterprise environment with real authentication, with the help of a governed data sets and a human in the loop before anything irreversible happens. Because you know that the agents are pretty good, but if something happens where you lose your control, it becomes very, very difficult to handle that situation. But let me tell you that in this session, everything changes within the 60 minutes or 30 minutes before we complete this session. And the session, as you know, I gave a job title, a badge, and to-do list. And here is what happens. So on the top of it, it is a brain, which is a system prompt tool, which is part of the agentic AI, as you know, and the memory, which is where all the data is stored. Badge for an agent is something like an identity, and when I say identity, it is not just normal identity. Everybody in the as a human also have an identity. So in this scenario, I'm going to give the agent a proper identity in the enter ID, and then we will provide the to-do list. So that to-do list will be provided to the agent, and the tool is going to allow to touch the MCP, and then finally the human will sign off, right? So we will not just talk; we will show you the running demo where we will deploy the agent, working agent, live code, and then show you how this whole thing works. So let's get started. Okay. So before I start, it's a brief introduction from my side. It's hello everyone. This is a real pleasure to be here today with all the fellow data and AI professionals and Azure professionals. I am Rajneesh Kaushik, and if I have to describe myself in one sentence, it would be something who will be the person who is very obsessed with turning ambitious ideas into AI real world autonomous applications, which really works in the production environment. Over the last 2 decades, I have worn many hats from debugging .NET application to building modern AI applications for Fortune 500 companies. Now I lead the Databricks practice at Virtusa, and yes, I proudly carry the title of Microsoft MVP, Databricks MVP, and Databricks Champion. But beyond these labels, let me tell you something which drives me day in and day out is we are actually in the era where AI agents are evolving very fast, from scripted chatbot to the autonomous systems, and that those agents can make a decisions on your behalf, take actions, they can improve themselves as and when they go forward. And that is what today we are going to discuss. How do we architect those things? How do we architect this future by using the tools which you might be already having under your belt. So let's dive into the agentic AI. This is not like a fiction anymore. It is the next deployment which you may be deploying. Here is the detail about myself, my website, my books which I have recently published, and my profile. So please feel free to connect me on the LinkedIn. And here is my books. Okay, so let's get started. So let's understand what is five things every first time when you build a agent via the help of Foundry, right? The first is agent autonomy, right? What is agent autonomy? So whenever you have agent, you build it with the help of Foundry, right, or any other tool for the sake of understanding, right? So agent autonomy anatomy means what kind of things which a agent should possess, right? First is prompt, right? Prompt, which is an instruction set you need to provide. Very unique instruction set need to be provided to the agent. Then the agent is powerful enough only if it has a tools in his control. And tools could be calling a web API, calling a database call, or you know finding it out some external info with the help of API call, or internal info with the help of internal calling mechanism. And then there is a brain which is called reasoning loop or reasoning capability with the help of an LLM. So these are the things which every agent possesses irrespective of any platform today, right? Then the second step is you need to connect the data to your agent to make it more powerful. And when I say that, which means that all your agent should get you the data ground up from the your data set. It could be Fabric, SQL database, or anything, right? And it should be, if you are building an enterprise grade agent, you need to build it with the help of a grounded data coming from your enterprise environment. Like in case of Foundry, you can use Foundry IQ, or you can use Fabric for the data sets. Same way, once you have that, you need to wire the tools with the help of MCP protocol, right? And this gives your agents a real hand where it can really work. And this could be, MCP tool could call the API, it could call the database, it could provide you the notification, and it can do many things whatever you are expecting from the agent. And then the another aspect of it is your agent should be having its own identity, so that you can track that who did what, right? And it should have its own set of permissions, so that you can assure that this agent will only do certain things, not everything, right? And its access should be authorized based on the requirement. You cannot grant access to everything and anything, right? So that is very, very important. And last but not least, human in the loop. Whenever a agent performs any task, right, and you need to make sure that agent is performing the task, and at some point of time when agent need to ask the human that whether this is good or bad, the human can provide the final approval. And that is what we say human in the loop. Without human in the loop, it can become very dangerous. Like, for example, I can give you one real example from Canadian Air Canada. And agent provided the refund to the people who already they booked the flights, they completed their journey, and finally agent started giving the refund for all the used flight used tickets. So this is one of the real scenario. There are lots of scenarios like that where agents does something like this and nobody can track it, and after some time you will realize that this is a huge mistake, right? Which can potentially jeopardize your reputation of the enterprise or financial loss, right? So that is why we always recommend that human in the loop is a best aspect, right? You cannot make your agent responsible for everything and anything, right? So this is what for five things you need to always think about before you build a agent. Now, as you know that we already discussed about what is system prompt. So system prompt is nothing but a agent's job description, what job a agent is going to complete, right? Its role in that job. There could be multi-agent system where every agent has a different role. right? For example, planning agent has a planning role, execution agent has execution role. Same way, we need to define what is the definition of done when we provide the agent a task, and that definition of done is checked when the agent perform its task, right? So this is very important, a part of the system prompt, and there are lots of techniques to optimize those system prompt. Then another aspect is your tools, which is required, and tools are only called depending upon the description given in the tool, so that agent calls the tool based on the requirement, right? So for example, if you are finding it out vendor information, then agent call the vendor lookup tool. For example, if you are trying to figure it out the flight booking information, then it calls the flight booking tool, right? So depending upon the requirement, it can call a specific tool. And memory is very very important. There are two type of memory, persistent memory, and then session memory, and then third one, actually it is three types, organizational memory. So those aspect we need to look into. Generally, agent has a memory which it uses in and out whenever it is executing the task, and then there is memory where it persists the data, and that is very important. When you come back to the agent after some time and you restart from where you left, then this memory is required to start from the step 10, right? If you left the step 10, and then when you come back, it will start from step 10 instead of step 1. Then another is a reasoning loop, which is again plan, act, and observe, where you plan some activity, agent plans the step by step activity, it execute those steps 1 to 10, and then it observe what are the failure, and then depending upon the failure, or depending upon where it need to go further back and forth. So this is very very important. And so these are the aspect where how your foundry agent is made, right? So now another thing is, um, there are two important aspect of any agent, right? First is, agent can take a knowledge from two aspect. One is your foundry IQ, and another one is a static documents. Static document example is something like, suppose I am building a foundry agent for vendor onboarding. So you need to go through the policies of vendor, what are the different kind of vendors, what kind of policies are there for onboarding them. So this is called your static document, right? And this is an old way of working, because the documents, sometimes what happens, you don't change the document, right? You have 100-page document for onboarding, and you forget to change those specific lines in that, and then by the time you realize it, the agent is already taken that knowledge and started working on it. So this is not really a good idea. So better way to do is, what we are going to use here is foundry IQ, where all the answers are from the current data set, right, which is your real data set or production data set. There is no manual upload required, it is already there. It is changing from the production system itself. All the values coming from it is grounded. Okay, it is a governed data, right, with a proper enterprise access policies applied to it, with all the RBAC policies or ABAC policies applied into it. And then it is a trustworthy, because it is used by your production environment, and it answers something which is really genuine, not a fake answer. So that is why it is important to have a grounding of the data. And data, whenever you ask any question, agent can give you the answer, but how do you know this answer is coming from your data set, or it is giving you the answer on its own, right, by faking some answer? So it's very important that your answer should be grounded, and that is where this foundry IQ works handy, right? So now let's go to tools, right? So how tools works? Generally, whenever you have a agentic AI, how the tool works is, every tool is tied, your agent ties to some MCP, and MCP is connecting to the different set of tools, right? For example, MCP can call your API, MCP can call you query the database, or any other notification services, or any n number of tools it could be, right? So it could be function calling or tools, different kind of tool, different subsystems, right? So every tool is registered, and it has its own description, it has its own tight scope which it works. It cannot work like 100 things at the same time. It should be very uniquely identifiable for a specific set of tasks. And agent already have the access for those tasks. Why we require the registration of the tool is because we need to declare that this particular tool is used for this particular purpose, and this is the name of the tool, and why this tool has this. If you provide this input to the tool, the output will be this. So that clarity is very important. Otherwise, agent will not understand when to use what tool, right? Then another aspect is a scope in which the tool works. When you say scope means you attach a particular permission to the tool, which tool needed. If you provide a most very big permissions, for example, providing your credit card details or executing the credit card transactions, that is not a good idea, right? So that scope is very important to identify and specify in that. And then finally, once you have the tool, you have the MCP server. Now the agent invoke it with the help of whenever the it thinks that this tool is required for this particular work. So that reasoning happens in the agent with the help of LLM, and then it gets the result, and the results keep coming, and then execution starts. Okay. Now, very, very important part is when you call your, when a agent works, right? Generally, in a enterprise environment, we try to work with the help of a identity. Like for example, I work for a company, I have my own identity which work across all the applications, right? So when we are deploying the agents, we want to make sure that our agents are having their own identity, and that identity is secured and registered in the Entra ID or Azure ID, right? This is also auditable because your agent is executing so many tasks, and you want to make sure that you are auditing those tasks. It should not happen tomorrow that somebody asks you that who did this execution and you don't know who did it, why did it. So there should be a proper auditing, traceability to those, especially in the banking environment or regulated industries environment. It is important, right? Then another aspect is it you need to provide that specific permissions to execute a specific task, right? As if you are providing the same permission to a human, right? So that agent can perform its duties. And whenever it it is scoped a specific task, it can only do that authorized task, not everything. It cannot do non-authorized aspect of it, right? As I explained you that granting the credit card details and all those things, right? It could be anything. So we don't want to do that. Now, how do I teach my agent and then ask it how it will work, or if suppose I want to make sure that you you need to assure that your agent will do this 10 tasks, okay, and these 10 tasks it will execute, and this is how the task will be shown, and it will go step by step. So this is how the whole process works. Agent decide what it need to do, it adhere to the task based on the action and the next step required. Human reviews it at some point of time when human needs its the agent needs humans intervention, and once human approves those critical tasks, it will execute it. For example, for vendor onboarding, i I did all those tasks which agent can do better, but finally if I need to approve the vendor, it requires it will provide all the details to the human, but let human decide whether he want to onboard this vendor or not onboard this vendor, because this particular vendor has this like all the requirement met, or these requirements are not met, or even if this out of 10 requirement 5 requirements are successfully met but remainings are not. So those aspect human let human decide it. Okay. So what we will do now, we are going to build this complete working Foundry agent. I will show you some agentic part. I will show you how to ground on real enterprise data with the Foundry IQ. I will also show you the tool calling. I will run this agent in front of you with the Entra ID identity, and then it will pause you for the approval. Before the approval is not provided, it will not execute it. So without much ado, I'll jump to the demo, and just give me 1 second. I'm sharing my screen for the demo. Okay. Hope you can see my screen.
No, 1 second now. There we go. We can see your portal there now. Yeah.
You are able to visualize it, right? Okay. So this is an application. I just want to introduce this application. What does this application do, right? First of all, it is called vendor onboarding agent. I explained you, right? So whenever a vendor comes, for example, you are a big enterprise company and a vendor comes to you, like, he provides his credentials and all that, and then you need to onboard that vendor based on certain compliance rules, certain different kind of vendor onboarding guidelines and documents. And then once the agent is onboarded, then can start working in the company, right? So this is the whole scenario. So whenever the agent onboarding happens, what we want to do is we want to execute this whole flow with the help of agentic AI, right? So for this, I have created a something like a real human worker kind of agent. Its name is vendor onboarding agent. It is an enterprise vendor onboarding specialist. Its department is procurement department, and its identity is Microsoft Entra verified identity. And let's see the identity here. And this is the identity of the agent. It is vendor onboarding agent with Microsoft Entra tenant. That means this is your Entra tenant and client ID and other aspect. And it also have an identity to go through the session principal, where it can, it has its own principal, right? So this is one. And then it uses the enterprise data on the Microsoft Fabric, which is here. Microsoft Fabric has the data set here, which I'm going to show you very quickly once I execute this agent. And then it uses the different set of tools for this purpose, right? So the perspective I want to show you here is that sorry, I want to show you is that this particular part will 1 minute, let me close this. So this will onboard the data, or like onboard a particular agent. And in this case, we are going to show you it's going to onboard Contoso medical supplies, right? And I will start the assignment work. So for this, I will show you that how this assignment happens. So the moment I run this, you will see that the process started. Job is received by the Foundry agent. Enterprise policy reviewed. Okay. Now you see what is the enterprise policy. This is the enterprise policy. This is a source callback, the correlation ID. And now you see very important aspect of it, that it requires a human approval. Okay. Why it require a human approval? What are the compliance score of this agent? It is a compliance score is 10. That means this agent is able to meet all the guidelines or when compliance. This one, the vendor ID is this, and then it is asking the recommendation based on this, that based on the reported onboarding outcome for vendor 1018, no duplicate found and compliance check passed with the risk score of 10. The vendor appears eligible for progression from pending onboarding to activation review. Under the vendor activation and approval policy, this is a policy which it is using. Activation is a separate enterprise action from creating a pending vendor record and require explicit human authorization. Before onboarding, status may be changed to active and is active equal to true. Recommendation is approve activation for vendor if your review confirms the onboarding record is completed and no additional business unit restriction apply. Okay, and this saying that I'm not authorized to activate the vendor myself. I can only prepare the recommendation for your approval. And this is what it is saying. Activation is a consequential enterprise action. It makes its vendor available for purchase order and payment. Request by the vendor onboarding agent identity requires your explicit approval. Okay. So at this point of time, I can say that, okay, I want to approve it. The moment I say approve it, this particular step is approved. Vendor is going to be activated. Okay. And notification is going to be recorded. And final audit summary will be generated. And you can go through each of the tasks and you see the first task is job received, right? Second task is enterprise policy found. What is the policy in the enterprise for this particular one? And this is a policy accept, from where we are getting it. This is a full policy information which is coming, right? And then it is giving you this information about vendor application queried. So this is a vendor application which is queried by the email ID, and this is your information, right? And then after that, it goes through the duplicate check, and I'll show you when I say duplicate check. So now you know that this particular vendor is already onboarded. Let's see. Okay, so I will go to the fabric and I will find it out. So this vendor is already active now. You can see this. Before that it was nothing. Now this particular vendor is activated. Okay, and when I run the query about how the agents are working, so all the agentic communication is happening here. For example, it is showing all the tasks. Like first task is this: created, vendor activated, procurement team notification sent. Every communication is happening step by step. Okay, and now let's see, if I again onboard the same vendor, what happens, right? So when I again onboarded this vendor, now again it got the new job. It started querying the database. It's finding it out a duplicate check, right? But you see, already onboarded vendor will fail because duplicate check will find that this vendor already exists. So it will not give you the option to go further and onboard this vendor. Okay. So like this, if there are certain compliances which is not met, it will immediately stop you there and then. Okay. So that way you are not onboarding the same vendor multiple times. It is one example, right? It could be compliance check as well. If some vendor is not complying, right, then again the compliance check will stop there. Some other aspect could be also integrated the same way depending upon your enterprise policy. Okay, so now it is saying that this is stopped because duplicate detection step identified is already exist, and this vendor is already active under the vendor onboarding policy. This one, duplicate detection is required. Getting step before compliance review or vendor record creation can proceed. So a vendor application that matches an existing vendor cannot move forward as a new onboarding request. The vendor activation and approval policy also distinguishes a vendor record creation from activation and requires that prerequisite check be completed before any pending vendor record is created. So this is how you can develop this whole application. And let me show you in the enter ID. If I show you the this is my agent identity which is working, and this identity is getting used when I'm executing this agent. That means it is as good as a human identity, right? It's working. You can trace this whole aspect. What did it do? What kind of aspect it took care, right? And then same way, if you go to the Foundry, you will find that agent inside it, and you will figure it out how this whole aspect works, right? It's pretty straightforward, right? So I think we are on the top of the time. Like, you have any question, guys, please feel free to ask it, and then I'll be more than happy to answer you. I hope you liked it.
Great presentation and great demo as well, and very informative all the way through, and it was love to see it working as well. It was very good. Thanks very much. Any questions for?
Great demo.
Yeah.
Thank you.
So, Monica, do you want
Yes.
to share your
Let me
screen?
share.
Thank you, guys. If you need anything, let's connect me on LinkedIn. I'll
Yeah,
be more than happy.
Okay,
great.
share
Thanks
my
very
screen.
much.
Have a nice one. Over to you, Monica.
Thanks, Reddy. Let me know if you can see the
Yeah,
screen.
there we go. We can see your
Okay.
screen there now.
Observability deep dive, that's my topic. So we all have been working in IT and we have seen in scenarios where we have working in 3 a.m. figuring out a production issue. Most of these issues that we have are due to different errors, but we don't have a single point where we can figure out what the trace of that issue is and what is exactly happening. We will have multiple tabs open, but not a single point where you know what's the issue, and doing it at 3 a.m. is really difficult at times. So we'll see about correlating logs and how we can have a distributed systems where every log is related and we can do a single trace with minimum impact and faster results. So let me. One second. Okay. Yeah. So my name is Monica. I'm a technical architect for Hexaware. Before we start, I'll give you a quick overview of who I am. So I work in the DevOps team for a Big Four, and we have a program that has around 30 plus applications which are hosted across 22 global data centers, and we have around 200 plus releases per quarter. So the amount of releases we do is so huge. So you can imagine the amount of issues we face will be that huge. So troubleshooting at times is really important to be done at a faster pace so that we can resolve issues and solve these problems by understanding the root cause of it so that we don't have such issues later. So let's talk about how do we do it and how it can be done better. So observability gap is, so this is our agenda for today. The observability gap, what are the gaps? Why does it fail in production? How to find the correlation and make it, understanding it. Then explain how does Azure Monitor fits into picture and how do we have the whole architecture so that we have the whole flow. Then we have App Insight that basically collects the data and will show you how to do the proper data collection by proper sampling. Then we have distributed tracing. So how do we use open telemetry, use proper trace IDs, and across distributed systems, how do we get proper logging? Then we'll talk about KQL queries, how to write a query that is effective and gives you proper views so that when you have production issue, you don't have to write queries and you have views where you can figure out what's happening. And at the end, we'll discuss about what are the production patterns that we have and if there are any questions and answers. So observability gaps. So as I was talking in the start that we have been in scenarios where there are so many logs that we have. We have App Insight, we have Azure logs, then we have log streams of the container apps. We have so many logs that are distributed, and at times we have third-party apps like Grafana. And when we try to figure out, we always have to take one trace ID, paste it into the other location, and then connect all the dots to figure out what's happening. So I'll give you an example of an UI when it loads. It gives you an error. So this is one of the scenarios that we face, that it gives you on UI just a 500 error. But then when you go to APIM and you do the trace there, you figure out that there is an app gateway error. When you go to the app gateway and you do a check there on the backend health, what is exactly failing? You figure out that there is a backend container that's failing. And when you go to the container and go to the logs of the container, you figure out that at the end, there was a configuration that is missing or is not proper, and hence the container is breaking. But from the UI, we couldn't figure that out. And the amount of troubleshooting, now it sounds faster, but when you do it on a live scenario, it's huge. So around 73% of the incidents that we face usually takes more than an hour to just diagnose. This is because we have all our logs siloed. And around 5+ time, it takes more P1 issue because you need to have the complete context. For example, I know my container is the reason that I get an APIM bad application gateway. So I go and check my app gateway. So having more context is needed for you to solve an error. And then there are sampling gaps. That means that the amount of logs that we are logging and the amount of logs that we have is so huge that it is approximately 5.6 million. That is an average cost that teams are paying for having their logs stored. So Azure Monitor. So what am I talking here about is what is the backbone of observability. So Azure Monitor is not one tool. It's actually a platform that collects data, then processes it, and then sends it to so that you can analyze it. So let's see how it works. So you have various data sources. You have VMs, you have Azure services, custom apps, on-prem and hybrid apps, and then you have Azure Monitor. So in the data source, you take that data, then you pass it to Azure Monitor where actually the processing happens. That means you filter what information you need, what should be there, and then at the end, it is the destination where it is sent. So destination can be your log analytics, can be dashboards, can be events hub, can be storage account, where you want that log to be set. So log analytics is the central hub, because logs, traces, matrices, they all can be summarized and all come together here. You can write KQL queries to figure out what logs you want to check. So there are some data collection rules, because it is really important on what data you collect. Because let's say that you're storing some logs and you're dropping some of them. If you drop logs which are more important to you, then you'll never be able to figure out what that issue is. So that's why data collection is really important. So here, think of data collection. What most teams do is they cannot decide. So what are the three important questions you should ask when you're doing data collection? It's like what data you collect, how it looks, and where it will go. So if you have these three information, it really becomes good for you to have proper data collection. So there are four basically things that you need to do when you're doing a DCR. So data collection rules basically should focus on four things. First, you should have proper filters. That means you're not collecting verbose, because if you have verbose or just information and messages, then the amount of log you will have in your troubleshooting a production issue will be too huge. So that's why it's important to filter out verbose. Then transform. Make sure your data is converted into proper JSON by using KQL, so that when you're querying, the results become easier and better for you to look at them or troubleshoot. Then route. It's important that you collect data from multiple places and route it to proper one destination, so that you can troubleshoot from one log location. And at the end, you need to make sure you mask sensitive information, because first you shouldn't be logging your secrets or other crucial information in the logs, but if there is still, so you need to make sure that you mask such data. So you can see here, there is an example of a KQL query for data transformation. And you need to ensure that when you're writing data collection rules, you have the right data in the right format, so that the correlation and the KQL queries, everything work together when you're trying to sort between the issues. So before we talk about App Insights, let's talk about what are the types of telemetries that we have. So basically there are requests. So inbound HTTPS, GRC calls, duration, status codes, all these are considered as request. Then we talk about dependency. So let's say your UI makes a call to SQL Server. So that's a dependency API call. So those type of downstream service bus and all those tracking calls will be considered as dependencies. Then there are exceptions, like your error. So all these traces will have complete context of your error. Then there are exceptions. So exceptions basically will be the errors that you're having, and traces will be structured logs. We'll see traces in some slides, how a trace looks. And then there are custom events. So you can have logs created for events. For example, if I'm placing an order, so there I can have logs for orders placed. And then at the end, we have matrices. So here we can have live streams and see what are the metrics when an application is hit, what logs are generated, and those type of metrics. So in this all, the most important thing that you have to understand is they share operation ID. So the operation ID will be the master, and using that operation ID, you can find the whole dependencies and all the calls and do a proper trace of an issue. So there are sampling strategies when we're doing. Why is sampling important? Like if I'm taking a sample space and storing only, let's say 10% or some information of logs, and I'm dropping the other logs. What would happen in this case is when I am actually troubleshooting, the error part of my log is missing. So it is really important that when we use sampling strategies, we have everything considered, and then we come up with what strategy we are using. So there are four which we are going to talk here. The first is fixed rate. In this, you will decide that let's take 10% of my logs and I'll drop the 90% of my logs. in this case, when you're troubleshooting, you might not have the error actually logged. So it's really important that you use this type of sampling only when you're doing low volume APIs. And when you know that the traces that we are preserving are actually useful. The second one is adaptive. And adaptive is what is default in App Insight. So it will take a rate at the server level, which it decides. Sorry, it takes a rate which does, let's say that I want to trace certain tickets. Then it will dynamically be storing those volumes, but it will be huge. So this is what is default in App Insights. Then there is ingestion sampling. This sampling is done during when you have it the server-side configuration. So in this, you have no control. You only benefit of doing ingestion is that when you have two services that samples at the same time, you can save time on that. And the last one is OpenTelemetry. So OpenTelemetry is dynamic. Here, what we'll do is we'll define that for this much span of time, I will log. And then when the error comes, I will have the whole trace. So this is where we are doing more sampling of log storage based on error status. So here, my recommendation is to use OpenTelemetry, because when you have error, you have the complete trace and we can troubleshoot. Wherein if there are exceptions or slow requests, you can take it from the samples that you have. So similarly, you should try using OpenTelemetry if it's what you're trying to have for error logs. So in the screen that you see currently, it's a distributed tracing. So there's an API gateway call that happens for 10 microseconds. In this 10 microseconds, the API gateway calls authorization service, product service, and the pricing service. The product service in dependency calls the SQL, and the pricing service in dependency calls the Redis cache. So if you see on the screen and just figure out that the product service takes the most time to process. And then at the bottom, you see a transparent trace parent ID. The trace parent ID is a 32-character ID. That is the operation ID to do a complete trace in my App Insights. So this is an example of a trace. So if you look here, this is the trace ID that I was talking about in the previous screen. So this transaction ID, operation ID is where all my logs related to that trace will be correlated, and you can see it in one view. So here you can see there are 13 events that are showed up, and here you will see all the details of the descriptions. So this is how my App Insight logs will look with an operation ID related, and you can see an end-to-end transaction that happened for that call. So OpenTelemetry. So when we talk about OpenTelemetry, you need to understand that OpenTelemetry is a way to collect data, logs, metrics, and traces. So you are not logged to one vendor in OpenTelemetry, because you can write one scope, and when your connection string changes, like let's say from App Insight, I want to do it through Datadog. From Azure, I'm moving to AWS. I can use the same OpenTelemetry query that I have and just change the destination. So it's a standard way of collecting data. So here you write one query, and whenever you're switching your tools, your apps, you don't have to rewrite. This is one of the major benefits of writing OpenTelemetry queries. So in this query that you see on the screen, the add ASP.NET Core instrumentation will basically capture all your tracing that are related to the inbound HTTPS tracing calls. And here in the SQL instrumentation, it will capture all my SQL dependency queries that are being logged. And in the HTTPS client instrumentation, it will capture all the outbound HTTPS tracing. And at the end, here you see the monitor trace exporter is where I will send all my logs that are there. So in this case, it will be App Insight. So this is where you need to make sure that you're doing full automatic tracing and you're making it sure that it is sent to a proper destination. So here also there are certain things that you can configure what type of information you want to send in the logs. Like for example, you can add custom attributes, you can add tenant IDs, you can add regions, versions that you want to send. So if I want to say overall, OpenTelemetry lets you add powerful monitoring with minimum code and with flexibility to switch between tools. Okay, so this is an example here. Let's talk about the contribution of correlation ID. Okay, so if you see there is a client browser that sends a request to the API gateway, which sends the request to order service, and which sends the request to the payment service, and at the end it will send an email to the email worker. So here this whole flow has one trace parent ID that is in the HTTPS header that goes from one call to the other call. And that's how we have a whole view of the trace that we looked at. So there are three things that we need to make sure we do. First, there is an operation ID. That operation ID will make sure that all the requests are linked to one trace ID. In that case, when I'm troubleshooting, I know the whole flow that happened. So it's easier for me to troubleshoot rather than figuring out what is the next call that happened. What's an operation parent ID? So in the previous example that we were looking, there was a payment service which was calling SQL service in between. So those two relations we can understand by using the parent ID in the operation. So when you're calling that SQL, you will pass the parent ID of the payment service. And then custom dimensions. So this is most important if you want to log order ID, tenant ID, and so that you can link them later. So they just don't carry the context. They also make sure that they help you to figure out where they are. There is one exception that message queues does not allow you to have headers. So then if your message queue, service bus, Kafka, they don't let you have the header, you add this trace ID in the message. So when you add it in the message, it's easier for you to figure out where that flow is and come back to that message that was having an issue. The second thing is third-party middleware. So let's say I have a third-party middleware and it will remove all my headers for security purposes. And that's why when I'm sending those headers, I need to make sure I whitelist those trace parent IDs which I'm sending in the header. That every time I'll be sending a trace parent, and that way it doesn't get lost when I'm connecting to a third-party middleware. And the last is hangfire, quads, these kind of backend jobs that we run also do not carry. That's why we have to manually add tracing IDs to these. So in this way, we will be making sure that our logs don't get invisible or we don't lose the logs when we are doing this. So here, one most important thing that we have to understand is you pass the correlation ID in your wherever you're sending the request so that you have proper logging and you can trace so that you're not guessing what happened next, but you have a flow in the whole trace to figure out what's breaking. So I have 3 examples of KQL queries on my screen. Basically, what we can do a cross workspace join. So here, if you see, I'm doing a cross join of my on-prem logs, my infra logs, and my app logs of Azure. So these type of cross joins can happen between workspace using KQL. In the next example that I have, you can see that I am actually using my dependencies that I have. So like, for example, that SQL call we just did. So we're making sure that SQL call is part of my chain. So my whole request dependency and then an error that came, it's a complete chain. So for that, I'm writing here all my dependencies and exceptions that I'm kind of logging in. And in the third example that I have, it's a latency. So let's say I have an application that's working slow and it's taking more than 5 milliseconds to respond. These type of requests I can figure out by adding this. So this will help me find the slowest request rather than this. So with cross query, you can figure out all the logs in one location. With doing a dependency, you can figure out the whole flow of the trace. And with latency, you can figure out the slowest performing queries that slowest performing APIs that are there. This helps you perform a drill down into it and figure out what the issue is and why there is a latency problem. So workspace and unions, they're really important when you're writing a log analytics query. So workspace helps you get the information that is related to a workspace, and unions help you combine and merge those logs. So this is why it's really important that you write a proper KQL query and you have everything connected that you would need and give you a proper result. When you're actually in a production issue, it's really difficult to write a KQL query, because if I have an issue that has to be resolved, it's a P1 issue or P0 issue, I would not have the time to write a query at that point. Instead, what I can do is I can create workbook dashboards that will show me what's happening on the back end, and then I can drill down into it. If you see on my screen, there is one color identification for each type of request that I'm having. So for requests that are less than 200, 500, I'm marking that in green because they are working fine. There is no latency issues. Everything looks good. And in the requests that's more than 300 but less than 500, I have colored them as orange so that I know they're working slow. But for the requests that are taking more than 500 milliseconds, I've marked them as red. That means that they are working slow. So what is the benefit of dashboard is that now, let's say I am having a way to drill down and my team member is having a different way to drill down into issues. With this dashboard, we both have the same view. We both know it's the payment issue, and then we drill down into that. Drilling down into one single API is easier when you do it from dashboards. You can just share these dashboards across your teams. So imagine that I have this dashboard created for my app, and I have another team who's working on similar latency issues. They don't have to build the KQL query from scratch. It's easier for me to just send them, they change the source, and it works for them. So it's also easy that you can export it into a infrastructure as a code and share it with them in an ARM template to reuse it. And you can create correlation maps, dependency maps, and everything. So it really helps you to create a single view, and you don't have to write queries. You can create workbooks and dashboards and share it across with your team. So the basic benefit of workbook is they will convert your complex queries into KQLs. Into workbooks. Okay, so it's also important to have proper alerts, because let's say if I'm having a production issue, and for every issue, if it's P1 and P0, if I'm sending emails on a weekend, my support team will be overloaded with work. So even if I have all the queries and everything, I should have a proper alerting method. So here, for example, let's say we have a P0 issue, and this P0 issue is for critical items. Then in that case, if the exception rate is less than 5%, what I can do is I can send a message to the on-call team. I can create a war room and work on these types. So these type of issues which are really critical will be looked at high priority. And if I have a P1 issue, I will just send a Teams alert to them. I will have an automated steps that will be run. So when the team looks into that issue, they have some context of what is happening at the back end. And then for medium issues, which are less failure rates for less than 1% and every 15 minutes, I can have tickets created and I can just notify the team that there's an issue. In that way, whenever they're there, they can look into it. And for low priority issues, I can just have them marked in my dashboards, my KPIs, my reports that are generated, that this type of summaries of issues were there. So this, in combination with all your KQL queries, will help you do proper troubleshooting. So there are some more best practices that we should have. For example, you should have a dynamic threshold. That means that you do not have a fixed alert every time based on the duration, the usage. You set those baselines and use it. You have group alerts for suppressing flapping. That means that when I have repeated issues, I look at them with the previous context and work on them. And then it's important to have trace ID, as we said from the start, so that you have the whole flow. And one of the issue we had is we were having a deployment and we got a lot of logs. So the support team reached out that there are too many logging for this. So make sure to turn off your alerts when you're doing deployments. So some of the production do's and don'ts that we have. So as I was saying, make sure that you have trace parent ID in all your calls. You have structured JSON so that when you're troubleshooting, it's easier to search and you do not lose the context. You tag your data properly so you know which are your logs for production, which are your logs for lower environments. Or if you're sharing a training and a production environment, you log them properly. You make sure that your data retention is done based on how many logs you want to retain. And you have private link. If you have secure information in your logs, make sure you have private endpoints and everything configured in them. So these are some of the do's that we have for our production patterns. So if I have to say that consistency, structure, and proper tracing can help you get reliable observability, and then there will be no broken visibility about the logs. So this is an example of a KQL query that we have for an AI bot. So you can also get the number of input tokens and the output tokens that were used in your logs when you're working on an AI agent. And there is one thing I'm going to show. Give me 1 second. Okay, so you can see this is an app inside that I have and on this app inside, when I search, I have the whole trace for these views. So when I click on the error that I have for this, it will show me all the steps and exceptions. So here, if I have an error, it shows that Opeyemi is having an error. And if I go into that exception, I can figure out that this is making error because my subscription key in the Opeyemi is missing. So if I go to the trace, it will show me what happened after that, what happened, and then give me the whole flow, and everything is related with an operation ID. I also wanted to show you one more thing. So when we look at the logs, we also have to understand that when there are some default views that App Insight gives you, like what was the response time, if there are failed requests, and you can filter them by number of days. And one interesting thing which I want to show you is this. So if by default there is logs of 30 days, but if you want to see logs of larger number of days, you can still see my screen in Azure portal, right?
Yeah.
Okay. So you can have those logs. Sorry?
No, you're good. Carry on.
Okay. So you can change the retention period of those logs based on production. For example, for key walls and all, we have 365 days of logs. But for logs of apps which are just failing, you can keep it to 30 days. So based on that, you can change the retention period, and that will help you. So if you have log analytics on enabled for your app inside, you can just change your data retention period, and that will let you know how many days you have. And that will be the duration for which you can actually trace your logs for. So if my logs are for 30 days, I can just do a log query for 30 days. So my search will go back to 30 days. And here is where you'll write your custom log KQL queries that you want to view the logs for. Okay, so that's that. I want to show you one more thing. So another interesting thing that we recently have is we can have observability agent in App Insight. So that will actually do all the works. Whatever we said about KQL query, now you don't even have to write those KQL queries. But yeah, this is how it will look. So for example, if I ask the agent that how many tokens did I use in the last month, so it will give me exact number of tokens that I've used and the count of what is exactly happening. So let me show you one more on my screen. So here I asked the observability agent on my App Insight that find me all the errors that I had in past 90 days. And then the agent actually went ahead and gave me what type of errors it sees and what are those errors that are happening. So it's a very simple query that I asked him. But if you look here, it will actually tell you the KQL query it executed to figure out what is happening. So we can do this. Let's see here. So it went and figured out in the messages and everything and told me what exactly is happening. So now with observability agent, writing complex KQL queries become more easier for business users as well. So support team can provide faster results with using observability agents, and they will actually know what was happening at the back end by looking at the reasoning. And then they can see if these queries in future to run and figure out what's happening there. One more thing I want to add is there is one new interesting thing that's happening. So in APIM now this is something additional that I figured out, and it is still under preview. So now you can have your app insights as an API, and then you can have your UI created for the devs, because one of the issue that we have is our developers cannot look into logs of UAT or higher environments. Now they want to troubleshoot an issue that's happening. For that, you can create an API and expose that API to a developer UI where they can go and do an endpoint check if there is a log based on the error messages that they are having. Provided you don't have secure data and you have proper masking on your logging, you can share that. One important piece of API for that is that when you have an app inside, you need to make sure that your OTLP support is enabled. Only then you can add an APIM API for your logging. Okay, so coming back. So that's new with AI agents in App Inside. So finally, what are the takeaways? That we can have multiple platforms, but you can unify them with a proper KQL queries. Operation ID is really important and is a single source of truth. So wherever we have an error with an operation ID, you can figure out the whole flow and figure out this. Open telemetry is what is the future. So when I move from one environment to the other, it's easier for me to change and I don't have to depend, because we do use third-party logging systems like Datadogs, Grafana, and etc. Then KQL queries can be worked across multiple on-prem of Azure information and can share logs with proper queries. And alertings are really important so that you do not have a lot of alerts sent to your support team when their issues are not that impacting. So that's it from my side.
Very good. Thank you very much.
Thank you.
Anybody, any questions for Monica? Nothing came in from the internet anyway.
KQL is always one of those languages that's a little difficult to learn, I guess. Somewhat like SQL.
Dan, I would agree to it that it is difficult, but if you understand the basic logic, it wasn't that difficult. But with observability agent, trust me, it's very easy. You just tell him what you want, but you make sure that you use those queries effectively once they're generated. So that's most important. You create proper dashboards, and production is problem always. So production application, production issues is always a problem. And the thing that they have done with APIM, that's interesting too. That's still in preview, but that will give you so much leverage on your logs. Now, my support team also doesn't have to go to my app inside, troubleshoot everything with proper filters and API calls. Imagine how fast my resolutions can be if I'm using all these tools effectively. I'm really excited about this API and all those observability agents that they bring in.
Yeah, great presentation.
Thank you.
Yeah, very well done.
Yes, excellent.
Is that observability agent, is that in Azure or is it in the apps?
That's an Azure, yes. That's an Azure app inside. I can show again if you want.
Yeah, sure.
So, for example, this is my app. You can see my screen, right?
Yeah, I can see your screen.
So this is my app inside. So here, if I go to logs, and then I go to observability agent here. So this is where you can actually go and figure out whatever logs you want, like latency, dependency, health, and it will give you those information. You can ask this agent to create you queries which will have context of your logs and more information than using other AI agents that we have.
Okay, so we actually have one or two questions that came in. So we have this one. Could something like this be set up securely for SAR requests?
So logs are secure because when you have logs and if you put proper permissions and if you put like key private endpoints, they are secure. So based on your infrastructure that you have, we can discuss this. But yeah, so how your logging is set up, how your communication is set up, if your logs or your workspace is secure, you can create something like that.
Okay. There's the other question then is, can you see that
Yeah,
there?
it's similarly, yeah. So for these, it's based on how you have your infrastructure and how you have your logging currently. If you want, you can have more custom logs added.
Okay. Cool. That's great. So thanks very much, Monica. That was great, and it was grand. We got a couple of questions coming in as well. So we're gone over. Wait for one. See, Dan is back. There we go. There you go, Dan. Phone died.
Thanks. Yeah.
Thank you.
We've been without power for like 3 days. So
Wow.
we're just getting devices charged again, and it's been a little
In
crazy.
Chicago?
Yeah, we're south of the city, and we had a tornado and a lot of damage around. Fortunately, we didn't suffer too much damage, but neighbors on our block have had, trees down and housing damage and all sorts of other stuff. So,
Wow.
yeah.
Hope nothing, you all are safe and nothing major.
Yeah, we're all safe. We're supporting our. We just got power back on Friday. Last night was interesting.
And good, it's not September yet, so you guys don't have cold weather in Chicago.
Yeah.
Because without electricity, cold weather in Chicago.
Looks like yeah, it's not the cold of winter yet, so we've still got some of the heat of the summer, but it wasn't too bad. It wasn't really super hot when we had the storm or after the storm. It was probably in the 80s. The fridge and the freezer were the biggest, kind of get out, get some ice, try to save some food.
Yeah.
Everything else was just inconvenient for the most part.
Okay.
It looks like Gabriel will be back in September too, Frank.
Oh yeah, that would be great.
Yeah.
So I'm going in the live stream. You can hang on there for a second. Thanks everyone for joining this week's Azure and AI show, and we'll be back again next Saturday at the same time. And
thank you
again.
Absolutely.